Hi, grade 12s. So, welcome to this one. This is a MATC one of the best. So, in this video, we're going to be looking at inverse functions. So, inverse functions can not be really that tricky. The main idea is to really have that critical thinking and that aspect of being able to manipulate your equations and functions as you go. So this is inverse. Oops, that's no way to write an S. Inverse functions. And in this inverse functions, so we really need to understand inverse functions. So inverse functions can be denoted in this. Let's suppose we've got the function f of x, and let's just say, for instance, our f of x is x squared. Okay, graphically, f of x, in this case, our f of x is a parabola. If you're confused, then really you need to revise your functions, but nonetheless, in this case, our parabola, if we actually take the idea of trying to graph our parabola, let's take the f of x is x squared in this case. Okay, so f of x is x squared is a parabola, and this is a parabola that smiles in this case. Let's try and use GeoGebra to try and graph this equation. So our f of x, will just say y is equal to x squared. So this looks something like that. This just has the turning point happening at the origin, and then it goes back outwards. Nothing fancy there. However, um, all what I really care about is the inverse. So what I'm gonna do is just draw that rough sketch so we can really understand the comparison between the two. So here is my parabola. That's my function f. Okay, so in your question paper, they can literally tell you to find the inverse, or they can tell you to find f negative 1. Okay, that power negative 1 doesn't mean go to x and put it x to the negative 1. That's not what it means. What it means is find the inverse. This just means the inverse of f. Okay, and when you are finding the inverse of f, or the inverse of a certain function, first thing you do is you make sure it is in terms of y. Okay, and when it is in terms of y, in this case in point, then you're going to swap x and your y. So you're just swapping x and y. So first things first, I'm going to take my f of x is equals to x squared, and I'm going to put it in terms of y first, and then swap x and y. Then after doing all this, you're going to make y the subject. Okay, but this is just doing this, making it in terms of y again step. But anyways, so let's do that. So first things first, I've got f of x is equal to x squared. So first things first, I'm going to put this in terms of y. And in terms of y, this is just y is equals to x squared. All I'm doing is just replacing the f of x part. Nothing fancy there. However, the second step then wants me to swap the x and the y. So instead of a y, I'm going to have an x, and instead of a x, I'm going to have a y and a squared. Then I'm going to put this in terms of y. That's my third step there. So to put this in terms of y, I'm going to get rid of anything this side that is not y. So to get rid of a square, I'm just gonna square root. So this will become square root of x is equal to y. Now this is my inverse. Okay, so let me mention a couple of takeaways when it comes to inverses. This is just some properties you have to keep in mind when it comes to your inverses. First things first, when you have your inverses, you're going to have a domain. Okay, let's say the original. Let's suppose you have the original function, then you have the inverse. When you have these two, your domain of your original function will actually become the range of your other function. And this is because we're actually swapping x and y, so everything that had to do with x would go to the y values of the inverse and vice versa. So that's the idea. And then the range of your original function would, yes, of course, become the domain of your inverse function. That is the thought and the idea. Let's try and see this in action, and let's try and denote everything that I've just said. So here, if we look at this f of x of ours, this that is our origin there. However, these things are going to swap. So this is my x and y intercepts. So what's going to happen is, let's try and write down the domain of this one, and let's see the domain of just the original function. So remember, domain is just talking about which x values does my graph cover. So here's my x axis. This y value, as it goes up, it's going to keep opening up more and more, and as it opens up more and more, it goes like that until infinity. So it keeps on opening up to the x this side and opening up to the right this side. So the domain of this one is just x going to be the element of real numbers, nothing fancy. It's just going to cover all x values. However, for the y, which is the range, now we're talking the range is all about the y values. When we look at the y, this graph, my original graph, actually starts from the origin 0 up until infinity, because remember we have positive values there. So this goes up until infinity in terms of y. So it only covers this part of the y-intercept, of the y-axis, sorry. It does not cover this part of the y. So then our range for this one is just going to be y. Then we have to consider the fact that it's going to breach, so y is going to be the elements of, and we're going to see the fact that it starts from 0 all the way up until positive infinity. Negative infinity is this side, positive infinity is that side. However, for the inverse, if we look at the inverse, let's since we've graphed this on GeoGebra, let's graph the inverse that we have there. So I'm gonna grab GeoGebra, and then we're going to attempt to graph that. All right, so there we go. There's GeoGebra, and then we're going to graph this function. So instead of us having y is equals to x squared, instead we're going to have y is equals to square root of x. And there we go. So now we have something like this. You're probably like, isn't it supposed to be a parabola going this way? Yes, but this is due to something that they call the domain restriction, which I'm going to explain to you in a bit. So let's look at this. Let's let's look at our x first. Okay, let's look at our x. So our x can be anything. It can be anything. So this is me looking at this thing of x. It can be anything, but hold on, there's something that the x cannot be. The x cannot be a negative. Remember, based on the rules of maths, you cannot put a negative under a square root. So I'm not allowed to put a negative under the square root. So I'm not expected my y to be using negative, to be having a negative. Okay, so despite what I put here, the square root of that will always be a positive y. I'm not sure if this is making sense. So on this x, I can put anything. I can put 1, 2, 3, 4, 5, 6, up until infinity itself. I'm still able to square root that. However, I cannot put in negatives. But here's the beautiful thing. When I square root any positive number, I still get a positive number. That's just number theory 101. That is just the basics of numbers. So no matter how small the number is, I still end up with a positive number. So this just means that no matter what number I put there, I just can't get a negative y, meaning my graph cannot cover the negative y part of the axis. So I cannot get a negative y axis. But let's look at the domain and the range for this function. We saw based on the domain restriction, but let's just imagine that I don't know anything about domain restrictions. Let's just say I'm dumb in this case, and I come out of nowhere and be like, yeah, I'm just gonna swap things around, and here we are, we cool. That's my inverse of f. We cool. I can go to the next question, but we have to then consider our domain and range. Okay, so if we go to the original equation, our original domain was x is the element of real numbers. Okay, by x being the element of real numbers being the domain, this is what my range will become. My range will become x's, but not x, but rather y is the element of real numbers. They swapped, so my range is apologies, my range is the one that's going to become y is the element of real numbers. This just means that my y covers everything. Now we're going to put a restriction to this, and I just saw the restriction based on my analogy using this inverse function that I just came up with. I just saw that my y will never be negative. No matter who I think I am, it will never be negative. But let's put a cap on that. Let's look at the domain. As for the domain, when we look at this original function, our range was beginning from y to positive infinity. That's what my domain is going to be. My domain is going to be from 0 all the way up until infinity. And that is really what's happening. It is from 0 all the way up until infinity. So that's what my domain is going to be. It's going to be x being the element beginning from 0 all the way up until positive infinity. Nothing fancy there, but here's my range. I I said that I'm going to perform a domain restriction due to the function itself not being able to carry the negative y's. No matter what I put in for x, I can just never get a negative y. Whether I like it or not, I can't get a negative y. So here's the negative y's. These part can never happen. So if I'm drawing my sketch, I have to then disregard the possibility and the idea of me having a negative y there. So I can just forget about it. That's just not going to happen. That is number theory. Okay? That's just an example of finding the domain, the inverse to a function, and being able to then identify your domain and range out of the function. So let's try another question. Let's try out this question. So this question comes from a mindset document, thanks to Mindset Extra. So I took this out of a mindset document, and here they gave us the function f of x is equals to n to the x, 9 to the x, and then we're given g of x to be that value there. Then they want us to sketch the graphs of f and g on the same system of x's. Now I feel lazy to go around sketching these things. So what I'm gonna do is I'm gonna let my uncle do that. I'm gonna let GeoGebra, my graphing calculator, to graph it for me, because I just feel lazy. But for you guys, you probably know how to graph functions. I cannot stress this much. Remember, when you're graphing, the first f of x there is a an exponential graph, and then the next one there that you have is in fact a parabola. So you just need to expand this, put it into a parabola, and sketch it. So I'm not going to stress myself too much on this. In fact, if you have problems with the sketching of functions, then you have to go back and really revise your functions. And I'll have some videos in future on just functions alone. But nonetheless, so I'm gonna call my uncle. There he is. So I'm gonna have it sketch the first one. So that's just y is equals to 9 to the x. So that's just y is equals to 9 to the x. Nothing fancy there. Okay, then there's another function that we're given there, and that one is a little bit crooked and a little long. So let me go back and check on that one on the board. So that's 2x minus 3 squared. So that's just going to be y is equals to 2 multiplied by x minus 3 squared. Then there was like a plus or minus there. minus 18. So it's this. Oops, move the cursor to the end. Minus 18. I have a 19 there. That should be an 18. There. Okay, nothing fancy in it. So let me see if I have that copied. I did not copy that correctly. No wonder I have a cubic function. So this should be a square. Okay, there we go. There, now it's a parabola. Okay, so if I zoom out of it, this thing has like a turning point all the way down there. But this is what they look like when you sketch them correctly. Nonetheless, and of course, if you expand them, you can see that this would become y is equals to 2x squared minus 12x. But this is not all about sketching functions. You should be a-okay when it comes to sketching functions. But my trouble is with the inverses, which is the question that follows. And the question there just says, find the inverse of f in the form y is equal to da 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 da. So let's take f, let's find the inverse of f. So what I'm going to do is I'm going to take f of x is equal to 9x. So this is number 2. F of x is equal to 9x. I'm going to put it in the form y is equal to 9x. And remember, this was a square. Whoa, I have this copied down wrong. Oops. So there. Yes, so this is 9 to the x and 9 to the x. Okay, then what I'm going to do is I'm going to swap the y and the x. So my x is going to become the y and the y is going to become the x. So I'm going to have x is equals to 9 to the y. Nash, yes. How do we make y the subject of the formula now? Well, to make the subject y the subject of the formula, we're going to swap this around. So this was an exponential equation, and to make this the inverse, we have to find a way to drop down this y. And to do this, we have to use logarithm, no way around that. So to use the logarithm for this case, what I'm going to do is I want you to keep this in mind. When you're changing into logarithm, remember that base remains base, whether you like it or not. So if y is going to become the subject of the formula, here's y. I want y to be the subject. In this case, y is going to be the subject. However, my base shall remain my base. Okay, the base of this exponent is 9. So I'm going to have 9. However, I'm going to say log, and then the base of this log is the base of what was the base of the exponent. So 9, and then x. Booyah. Oh god, I feel confident. And I have it in the form of y is equal to da 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 da. So that's it. Then sketch the graph of inverse of f x minus 2. So what they mean is take your inverse, okay? Take your inverse, and then instead of having an x, put in an x minus 2. So my inverse of x is log base 9x. However, for x minus 2, instead of me having an x there, I'm going to have an x minus 2. So this will just become log, okay? This will just become log um, 9. And then instead of having an x, I'm just going to have the x minus 2. And then this should be like all together in one bracket, like one big happy family there. And they want me to draw the sketch of that graph. So what I would do is I'm just gonna let my uncle GeoGebra do this one for me again, because I'm gifted and you're not. So to do this function, you guys are probably like, well, then how are we don't have a graphing calculator. How do we do that? You're leaving us in the wilderness, man. No, 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 I'm not gonna do that. So when it comes to graphing this one, the trick that I would do in the exam is I would um inverse this. So if I inverse this equation, it will take me back to its inverse with an x minus 2, if that's kind of making sense. So I'm going to inverse this, and then if I inverse this, it will actually become an exponential equation. And then while it's an exponential equation, you guys know how to obviously graph exponential equations. So I cannot stress myself much when it comes to graphing exponential equations. You know this. So all you would do is change this equation and then invert it into an exponential equation, and then you're good. Anyway, after of course, drafting it as an exponential equation, then you swap your y's and your x's, blah 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 blah. I cannot stress myself much about that. But anyways, here's how the sketch is going to be looking. So I've got y is equals to log base 9 x minus 2. Let me just highlight this out. This thing is the same thing as the natural log of x minus 2 over the log of 9. Don't stress yourself trying to wrap your head around that, but I'm just showing you this so that you understand how I'm going to put it into GeoGebra, because GeoGebra doesn't have those kind of functionalities that I'm looking for. So here it is. So I'm just going to add this on. So this is y is equal to, and then I'm going to have my log x minus 2, okay, as I was saying it, and this is going to be divided by my log of 5, like that. And that's how it looks like. So obviously my exponential equation would be coming from this side going up. However, the inverse would be the other way around, but there is the inverse if properly sketched. Okay, then the question that proceeds after that is asking for which values of x is the graph x of that minus 2 less than 3. So this sounds a little off, but this is just an inequality question. So I'm going to grab the eraser and just get rid of all this gunk. I'm going to leave the equation. So I'm just going to get rid of this. Okay, so they're saying for which values of x will the inverse of x minus 2 be less than 3. So I'm just going to put in the equation of x minus 2. So the inverse of x minus 2 actually got it in the previous question, and this is this that I just got. So so this is actually what I have. In fact, I'm going to write that down. So inverse x minus 2 being less than 3. This is what we have. So I'm going to substitute the inverse of x minus 2. The inverse of x minus 2, I just found it from the previous question to be the log base 9 of x minus 2 less than 3. And then I'm going to solve this as if it was an inequality problem. Okay. As if it was an inequality problem, as if I'm solving for x. So if I was solving for x, remember what I told you. I said that the base remains the base. Okay, so the base of my log this time would become the base of my exponent, and then the power would be the 3. So what I'll be having is n, my 9, okay, to the power of 3. Base remains base, and the 3 came out, and this would be less than x minus 2. Okay, and then it's a matter of solving. Well, what is 9 cubed? So if I grab my calculator real quick, because I'm not good at mental math, my 9 cubed in this case is 729. That's just 729. Nothing fancy there. That's just maths we know. 729 less than x minus 2. Then I'm going to transpose my 2, of course. Then this would become 729 plus 2. And 729 plus 2 is about 730, I don't know, rough math, 732 less than x. Beautiful. Done. Then I know which values of x will I have that possibility is happening. So describe the transformation that maps g of x into h of x of that amount. So what they're saying is, which transformation, how would I transform g into h? Let's let's put it down this way. Let me get rid of all the stuff on the screen, because now we're dealing with g of x kind of stuff. So I'm just gonna get rid of oops, I'm gonna get rid of this. I'm just gonna surround that and bye bye, and this too, and you, I mean you. Okay, so I will just make use of that space. So what they're saying is, how can I transition from this g of x, which has this equation, into an h of x, which has this equation? So what I'm saying is, I'm going from two. Let me grab this. I'm going from 2x minus 3 squared, no, x squared minus 18, and I'm changing this to essentially become 2, not rather 2 but negative 2x minus 3 squared plus 5. How am I transforming into that? Well, if I make the comparison here, really, you can see that first things first is that the graph is no longer positive. Okay, so this is actually a negative. However, that one was a positive, and also I have shifted those values. Okay, so if I expand each of these equations, let's take the this side and expand that one. So I'm going to be having 2x minus 3 and x minus 3 minus 18. All I'm doing is expanding here, nothing fancy. So 2, beautiful bracket, x multiplied by x, that's just x squared, x multiplied by 3, and this is going to be multiplied by 3 multiplied by 3, x multiplied by this negative 3 is going to be negative 3x, and then minus this negative 3x, I'm essentially just getting negative 6x, and then negative 3 multiplied by negative 3 is positive 9 plus 18. um, this is what I actually have, so I need to distribute my 2. So I'm going to have 2x squared minus 6x plus 9 plus 18. Then I need to simplify, well, what is 9 plus 18? Because that's like the only like terms we have there. So if I grab the calculator, because I'm not good at mental maths, 9 plus 18, this is going to give us 27. So that final would be 2x squared minus 6x plus, and we said this is 27, right? Yes, 27. So this is it for this one. However, for the other one, if I grab this and just get rid of all that, I'm just gonna hit the delete. Okay, so for the other side, remember all I'm doing is trying to find the transition that's happening between the two. So if I take this one and also expand it, really the expansion would be very much the same. So I'll be opening two brackets, x minus 3 and x minus 3 plus 5. And then I'm still going to get this very same thing. So I'm still going to end up with 2x squared minus 6x plus 9. However, I'm going to have plus 5. Okay, so this is where I would end up, and then 9 plus 5, once again, I'm not really good at mental maths, so you're gonna have to excuse me on that. 9 plus 5 is about 14, so I'm gonna get 14 on that. So I'm gonna get 2x, remember this is a negative the whole time, I keep forgetting the negative, and because that's a negative, this would make this a positive, and this one would be in fact a negative. Okay, so this is actually negative 9 plus 5. Oh, crap. Okay, negative 9 plus 5, and that's negative 4. Yep, negative 4. So I get negative 2x squared, right? And remember, we're not having a negative there. That's a positive 6x. And here we say we're going to have negative 4. What's that? Yes, negative 4. All right, so there's a transition between these two, and they're saying they want to know the transformation. So that is the transformation, really is the fact that we are reflecting one of them. Okay, so one of them, they have been inverted, not inversed, but inverted. Okay, so if we actually look at them graphically, if I can put them down, I don't know how I'm gonna really put this. Okay, let's grab, let me grab GeoGebra so I can show you how these look. So here we go. Here's my GeoGebra, and what I'm gonna do is I'm gonna add on that new equation that we just got. That's just negative 2x, that's just a plus 5. Okay, so I'm gonna add this on so you can see how that transition happened. So instead of that, we've got negative 2x minus 3 and then plus 5. Not minus 3, that's minus 2 squared, and then plus 5 there. So the orange one was the original one. So you see that's a smile and it became a frown. It was inverted. I'm sure you can see that. Now that you can see that there's an inversion happening, they were inverted and shifted. One is 27 and the other one became negative 4. And the difference between 27 and 4 is like 7, 6, 5, 4, 3. Quick maths about 23. So they were also then shifted 23 units. So these things were inverted. So one was a smile, the other one was a frown. We're turning one with a turning point there and the other with a turning point at 5. So that's the shift that happened. That's the transformation. They were inverted from a positive graph to a negative graph. Okay, then let me just clear out the entire screen. Yeah, let me just clear out all the ink. The next question might need the space. Okay, so for this next question, show algebraically that f of x plus a half is equal to f of x. This is a compound function. So the one has to show that f of x plus 1 over 2 is the same thing as 3f of x. We have to show this. So to do this, I would pick a side. This is more like a proof type of question. So what I'm going to do is I'm going to take the side, and I think this would be easier to um to prove than this side. So either side, let's start off with this side. So here what they're saying is take f of x and then instead of x put x plus a half. I'll do that. So there's my f of x. Remember, my f of x is equal to 9 to the x. Okay, so I'm going to put in a 9, but instead of an x I'm going to put in an x plus a half. That's it, question done. Okay, I really haven't proven anything. I'm supposed to prove that this is the same thing as 3 multiplied by f of x. So what this truly means is they're saying that I need to take this left hand side and somehow prove that it's equal to the right hand side. And if you're quite good with proofs, you can see that I have to work with my algebra until it looks like the other side. So to do this, what I'm going to do is I'm going to break down this exponent of mine. So to break it down, this would just become 9 to the x multiplied by, because this is addition, laws of exponents, 9 and a half. Okay, then once I have it like that, what I'm gonna do then is I'm gonna take this 9.5, my 9.5, I'm gonna let the calculator do the work. Oops, seems like I haven't been showing you. So there's that question. So my 9.5, I'm going to break down that 9.5 and just essentially simplify my 9.5. So we'll bring my calculator to come and play with our other kids. So there's the calculator. I'll just remove it here. Then my 9.5 here, well, 9.5, this is really cool, is 3. So we've robbed the system. So 9.5 is just 3. So I'm just going to simplify that like so. And we said that we should prove that this is equal to 3 multiplied by f of x. Okay, then we said the 9.5 is just 3. So I've got 9 to the x multiplied by 3, and this is equals to 3 f of x. Okay, however, I'm not done. So what I then need to do is, well, 9 to the x is, haha, this is getting really cool. So this is just 3 multiplied by f of x. Then I can say, therefore, my left hand side is then equal to my right hand side. Hee, this done. And those are some of the questions that can arise when it comes to these functions. And of course, they get better with practice. And good luck, and I will see you guys in the next chapter.